day, ladies and gentlemen. You are welcome to our lecture number 1 on Mcen508. But I have seen somewhere it is like 508, which is power electronics and drives. And this is our lecture number 1. My name is Kabir Ahmad Abu Bilal from Electronics and Telecommunications Engineering. Since this course is for you mechatronics engineering students, I think it is important to begin with basic revisions. The first thing we need to remember is this power electronics is a field that involves 3 aspects. There is a power, that is electric power engineering aspects. There is electronic aspect and the control aspects. The power engineering on its own, it is a discipline that deals with the static and rotating power equipment that are used in the process of either generation or transmission and distribution of electric power. While the electronics component of this course has to do with the solid-state semiconductor power devices and the circuits, which are used for either conversion of power from one form to another or from one level to another in order to meet a desired control level. And the basic parameters that are controlled, they are either voltage or output power. The power electronics can now be defined if we combine the above as a subject that deals with the application of these solid-state power electronics devices. We generally call the family thyristors. We are going to see more details, and which are used for the conversion and control of electric power. Now I want you to take note on this keyword conversion. Most of the things that are done in power electronics is conversion of the electric power, and if we want to understand more that conversion aspect, let us assume that this is the input terminal and this is the output terminal. And we should also remember from our basic electricity that electric power can either be in AC or in DC, where AC stands for alternating current and the DC stands for direct current. So wherever you want to change AC to another AC level, the electronic power electronic circuit we use, they are called cycloconverters. Sometimes you can call them AC voltage controllers, or you can call them matrix converters. If you want to change AC to DC, you use rectifiers. If you want to change DC to AC, like the case of solar power, which is DC in nature, if you want to change it to AC, you are going to be using inverters. Whenever you want to change DC from one voltage level to another voltage level, the same DC, you are using either converters or choppers as the power electronic circuit for doing that. Now let us look at the brief history as part of our revision. The first electronic device which was invented and used for application in this area of power electronics was mercury arc rectifier in the 1900. And then other components were invented, which include metal tank rectifier, grid controlled vacuum tube rectifier, and similar ones, and they have been used since the year 1900 up to 1950s. Then the first solid electronics component that was invented was silicon controlled rectifier, and that is what we call the thyristor family. The company that was responsible for its creation is Bell Laboratories in US, and it was in the year 1956. This is a solid state transistor arrangement which has P-type semiconductor connected to N, connected to P, connected to N. Then the second revolution that takes place in this era of power electronics is when this thyristor, that is the silicon control rectifier, was then invented in commercial grades. And the company that did that is General Electric Company. These power electronics then continue to experience some revolutions until now, where we have ability for conversion, for shaping and control of large amounts of power for different applications. The power electronics has so many areas of application. Briefly, the first one, a commercial area of applications, which involves heating systems, ventilating, central refrigeration, lighting, computers, uninterruptible power supplies, elevators, and many more in commercial field. In domestic area, we have cooking equipment, we have lighting and heating, we have air conditioners, refrigerators, and freezers. In industrial application, we have pumps, we have compressors, we have blowers, we have fans, machine tools, the arc furnace and induction furnace, which are used for melting metals. We have lighting control circuit, we have induction heating, we have welding equipment. In the aerospace area of application, we use power electronics in the fields of satellite power control, in the aircraft power systems, and the rest. In telecommunication sectors, it is used for battery chargers, power supplies, that is DC and UPS. It is also used in mobile cell phone battery chargers. It is used in power control at BTS. The BTS stand for Base Transceiver Station. This is what the common man call service. That is a place where they have their gadgets that are used for communicating or for connecting to customers that are calling each other. One is calling the other. It is used in the area of transportation, particularly in the battery chargers for the electric vehicles, which are becoming very common now. It is used in electric locomotives, in the trolley buses, which use electric engine or electric motor as the engine and tap electricity from the mains on the road. And it is used in automobile electronics. All the electronic system in automobile, they involve the use of power electronics, and even the engine control. And finally, it is used in the utility systems, like in the high voltage DC transmission, like in alternative energy sources, for instance, the wind power generation, or photovoltaic, which is solar power generation. All of them involve the use of power electronics and the energy storage systems. So the next thing is we are going to look at the devices, which are the switches, the components, the electronics components, which are used in power semiconductor application for power electronics. Basically, we have 6 of them. There is power diodes, power transistors, which are BJT in nature, bipolar junction transistors. We have power MOSFETs, which is metal oxide semiconductor field effect transistors. We have IGBT, which stands for insulated gate bipolar transistors. We have the thyristors, and we said these thyristors, they are the family of PNPN structured power semiconductor switching devices. They are family. We are going to talk more about that. And we have SCR, which is silicon control rectifier, and this silicon control rectifier is also a kind of a family, and within the family we have what we call the diodes, we have triacs, we have the SCR itself as a generic name. The thyristor is the most important of all the devices or the switches which are used in power electronics application, and for this the thyristor exists in different types. The first one here is what we call the force commutated thyristors. They are called inverter grade thyristors, meaning they are the thyristors that are used for inverter application. We said inverter is the circuit that changes DC to AC. The second one is line commutated thyristors. They are called converter grade thyristors. They are the ones that are used for conversion of what? DC from one level to another. We have number 3, which is get turn off thyristors, which means it is controlled by switching it off using the signal applied at its gate. Then we have reverse conducting thyristors, which means it can conduct in even reverse bias. We have static induction thyristor. We have gate assisted turn off thyristor, which is operated using the signal applied at the gate as well as other control mechanism in order to switch it or to turn it off. We have light activated silicon control rectifier, or we call it photo silicon control rectifier. As the name implies, instead of having a physical gate where we connect electric signal, it has a point where the light energy is directed, and when that light energy incident on that point, it will now be converted to electricity in order to control the operation of the silicon control rectifier. And finally, we have MOS, which is metal oxide controlled rectifier. So the next thing is power modules. This power module is nothing but a set of semiconductor power switches, the 6 we have seen. So the set in which they are interconnected into a specific orientation, specific topology, and which are enclosed in a single case. If you want to use, let's say, the power diodes, 10 of them, instead of using individually, they can now cascade them, interconnect them, and put them in a single module, maybe with 2 or 3 terminals, just for you to use it. They simplify the problem to you. And this is as shown in this figure. As you can see here, we have figures A, B, C, and D. We are going to talk about them more. The reason why they produce these power modules is to facilitate the design and to simplify the physical layout of these power electronics converters, so that it will be easier for the user to just take them and use them without the burden of arranging them himself. Then the most popular among these topologies of power modules which are available are either single phase bridge rectifiers or 3-phase bridge rectifiers. These power modules, they are connected. They have several switches inside, as we have already mentioned, and these switches are connected either in series or in parallel, or even combination of series and parallel to one another. And the reason why we use the series and parallel connection is to increase the voltage or current rating. We need to remember that whenever you have electronics components in series, they have the same current. So if you connect them in series, you are trying to get a higher value by summing the individual voltages, but the current remains the same. If you connect components in parallel, you are having the same voltage, but you can sum up the currents. So we use series and parallel connection for either increasing the voltage or increasing the current respectively. And of course, sometimes you can use series and parallel together for a particular objective to be achieved. Now, if we come to this model, this A is the one that is called IGCT, which is insulated gate controlled thyristor, which means it is a combination of thyristors that are put together. And the second one, that's the B, is a power module that contains either BJT, that is bipolar junction transistors, or MOSFET, which is metal oxide semiconductor field effect transistor. The C is the power module that contains IGBTs, which stand for the insulated gate bipolar transistors. And the last one, which is the D, is the one that contains MOSFETs, and the MOSFET stand for metal oxide semiconductor field effect transistors. So ladies and gentlemen, this brings us to the end of our lecture number 1, which basically look at the revision aspects. God willing, in our second lecture, we are going to be taking those switches we have seen, the 6 of them, and discuss them one after the other. I advise you to watch this video over and over again. If you have anything that is not clear, whenever we meet in the class, you can bring it forward for discussion. Thank you very much till we meet for the second lecture.